Welcome to the Intersecting Us podcast, where math and life intersect.
In today's podcast, Brian and Dave explore the intrinsic meaning of math.
Well, hello. I hope as you come into our podcast today that you've been able to do some fun work and have some tasks in your life today, yesterday. You will have some tomorrow. But we all know that when we're doing tasks and we're doing different things in our life, that it's really nice to have them be meaningful, know why we're doing them. If you've been following our podcast, or if you haven't, we have been going through a book by Francis Su called Mathematics for Human Flourishing. And today we're going to talk about meaning. That's what each chapter just has a one-word title, and this one is meaning. And one of the quotes in there on page 38 of the book, Francis says, meaning is a fundamental human desire. And it's really an interesting philosophical quote coming from somebody who's such a math geek. But we've also got another math geek on. Of course, Dave's here with me. And I used to be one of those. I guess I still kind of am a math geek. I'm a geek, I know. Whether it's math or not, I'm not sure. But this was a really, and I know this is a pun, but I think it's pretty good. This was a really meaningful chapter for me. It had a lot of good stuff in it. And I know, Dave, we talked a little bit about it already, that there's a lot in there that you really gleaned from it. So what really hit you when you read this chapter of meaning in Sue's book?
Well, hello, everybody. It was a very good chapter. And one of the things that caught my attention was I realized how much meaning math has to me. And I realized that it's something that's really difficult for me to articulate why math has so much meaning. And I'm still trying to find a good way to articulate that. Hopefully today I can start that process, but more than likely we could come back to this a year or two from now and I will have better words to explain why math has meaning to me. But for now, I'm still trying to find those perfect words to explain it. But that doesn't mean that math doesn't have meaning. It has a lot of meaning, but trying to explain why it has meaning, that's the part that I'm finding challenging. But this chapter was a really good way to jumpstart that communication process. And I think maybe the first thing that jumped out to me was a quote, and it said, in all of mathematics, there's this lesson that objects are not as important as the functions between objects. And so I kind of thought about that at first. I wasn't quite sure what that really meant or how important that was. It sounded kind of sophisticated. But the more I thought about it, the more I thought it really meant something, because there's so much in math I get excited about. I get excited about the Pythagorean theorem. Why do I get excited about the Pythagorean theorem? Well, it's not just because there's a triangle and there's three sides to a triangle. It's all of the relationships that you discover about what a triangle is about and what the Pythagorean theorem reveals. And as you dig deep into it, you find that a triangle has been amazingly, what I would say, engineered. And we don't think of a triangle as being engineered. A triangle is just a triangle. But as you learn to uncover so many interesting properties, it's like, wow, that really is amazing. And so as I think about it, I think this quote just kind of nailed it on the head, is that what makes it interesting, what makes it bring meaning, is how different parts of math work together. And I think for people on the outside looking in, they don't get that because they just see a triangle. They just see numbers. They just see textbooks. And they don't see how things are connected, how dots that seem to be unconnected come together and become connected. And so that is, to me, a good starting point explaining why math has meaning to me.
Yeah, and in his book, and he did a good job of using that word. He uses the word story a lot. And I know you do too. That's probably why you resonated with the book, because you're the one that found this. I just kind of come on for the ride. But he talked about math explorers. Exploring is like exploring stories, and stories are a part of retaining new knowledge. And so, I think you did that in an earlier podcast talking about, we're not talking about story problems, that nobody likes those, but it's the idea of And he moved into that. I thought he did such a good job with that. The way he put it, he moved in that idea that when you're looking at it, stories, like you're talking about the Pythagorean theorem, yeah, you can just look at the numbers and that's good. But what's the meaning? What are you doing? And he said a virtue in doing all this is the quest for looking at things abstractly. I thought the way he put that, and I think that's a little bit what you're talking about. And he said that I remember there was a class I took at Simpson College that was called Abstract Algebra. I don't know if anybody else had to take that one for their math major, but I remember the first half of that class, I was getting an A. I had no clue what I was doing. I had no clue what it meant. I just knew how to do it. It didn't have any meaning. I was able to do the math, but I didn't know why I was doing it. I was able to go through. But when I stepped back and the professor said, well, think about this way. And it wasn't quite like Sue's saying here, but it was similar. And he said, think about abstraction as not stripping away the meaning. And you're doing this because you already know the answer, but bringing in more meaning and enriching the meaning. And I thought that changed a lot. And he talks about that here, how hard it is to do something in any discipline, but certainly in math, if you don't know why you're doing what you're doing or what is the meaning. Yeah.
Yeah, I can relate to that. And I think that's a good way of looking at it, that many people think abstraction as something that takes away all the meaning out of something, is that because, you take away the color, the texture, the sound, and you remove a lot of those things that often are pleasing to our senses. But what you're gaining from that is you are retaining what is essential. And when you look at it that way, that abstraction removes the things that are not necessary and retains what is essential. Now, that's a different way of looking at it. I know in my day job, I create videos. And when I start out with a video, I may have 30 minutes of information that I've gathered, and I feel like I could speak about a certain subject. But as I play with it, as I read through it, as I digest it, the goal is for that to get down to like half of that, like 15 minutes. Because what I want to do is I want to strip out all that is not essential, so that what gets presented is just really the important, essential, what is essential. And so I think math has a unique way of doing that in a different way, but it removes all the things that sometimes cloud the facts of what is important, and you can strip down to the math, and you get to what is essential. And so that's kind of like a fine art or a fine skill to develop.
So when you get rid of the non-essential elements, or at least set them aside, then you do have a better chance of finding the underlying meaning. And then I think probably patterns, between one problem or proof and another. But that as you were saying that's almost what you do in like philosophy. Or even if you're having an argument with your spouse. It's like sometimes, or you're having some litigation. A lot of times it's the non-essentials that get in the way of getting the underlying meaning. Yeah. And then you don't see the patterns so much, certainly so much true in math. But there's an old quote, I can't remember. And this is true, I think, in theology. I think it's definitely true in philosophy. Maybe it's true in math. It was in essentials, unity, in non-essentials, liberty, in all things, charity. And I never thought about that from a math standpoint. But again, it's a kind of the opposite way of stripping away, of looking at stripping away the non-essentials till you get to the essentials. And now we can talk about and we can see the patterns. And I think he hit that, if I remember right, in that chapter about without stripping that, you probably won't see, and you end up wrestling with stuff that's not has anything to do with the underlying meaning, which I always think that's cool. That we've seen that a lot in videos and just discussions in our podcast. How much, and I know it's cliche, we're trying to intersect math and life, but it's really neat to see how often it just kind of does that itself.
Mm-hmm.
And I think this was one of those times as we read through this meaning part and getting to that underlying patterns and meaning.
Mm-hmm. Yeah, and you just take something really basic like our number system. You can start with the integers 1, 2, 3, 4. We could have 3 dogs or 2 cats or 5 giraffes, and all those things are very different from each other. But when we simply focus in on the number, then when we say 5, that could represent 5 giraffes, 5 elephants, or 5 of anything. And so that's just a very simple example of the power of mathematics, is to focus in on the abstract part. And I think one of the things that people struggle with, like in geometry, you work with circles and triangles and things like that, is they think, well, when am I ever going to use this? When am I ever going to use this information about a circle? And we fail to see how many times circles appear in real life. And many times they appear by themselves. Like I can look on the that wall hanging you got behind you. It looks like it's, the picture of the earth. And it's kind of like two circles. So it's taking the sphere and breaking it up into 2 circles. So that's an obvious circle. But other times it's not as obvious. You could take like a toothpick, and that looks like, okay, that's a straight thing. But then if you rotate it around like a clock, it's going to go around in a circular orbit, a circular motion. And so the path that the toothpick follows as you rotate it is a circle, and yet the toothpick itself or the hand on a clock is straight. And so there's so much of that going on in math, where basic shapes are out there in this world, and they may not be apparent physically, but they may show up as we put things in motion. And so when we learn about the basic things about geometry, it prepares us to be able to answer so many questions that pop up in life with regards to circles and triangles and squares and ellipses, and the list goes on and on.
Well, and I think that you start talking about, it's kind of what we would call the existential part of math, where you experience things over and over again. And if any of you have taken an exam, whether Dave's still an actuary, I'm just one that plays one on podcasts. But when you see the repeatable pattern, I guess is my point. That's the idea. If you understand the underlying meaning, you're like, I know that one. Now I'm going to have to work it. I'm not just going to say, I know it. And they're going to say, oh, he knows it. You get 100%. No, you've got to go through the steps, but you know them. And we all have that, I guess, all that emotion. We've all had that emotion. It's like, I know this sucker. I know this. You're not tricking me on this exam. And so it has that, I think, the idea that when you see that, it kind of comes back to almost when you see there's what the meaning is underneath it, you see the pattern. You see why they're doing this. And then it just makes it so much easier than trying to just remember, well, I've got to remember the 19 steps, how this works. I don't really know why they work that way. But this is, and you see that in, philosophy too. It's like we can study Socrates and Plato and all kinds of different philosophers. Just knowing what they said is not really that big. How do I apply it? How do I apply it? Well, and then, like you said, how am I going to use this in my life? Well, I think there is. We'll actually get to that in our next podcast, talking about maybe playing around with stuff a little bit. But in this one, I think the meaning is so important. And I know in past podcasts, and we've had discussions just privately about math education. And I know I've given you some examples already that I think so often in math education, you're given a concept and you're asked to exercise it and do these exercises, but you're not really taught its underlying significance. And so you can go through and do it, but you really don't know. You don't really know why you're doing the steps.
Right. And one of the best benefits of math is also potentially one of its biggest disadvantages or challenges, and that is that everything builds on each other. Not everything, but so much of math builds on each other. So you start out learning the integers, then you move to fractions, and then you move to irrational numbers, and then you learn how to add, subtract, multiply, divide, do exponents. And, eventually you're going to get up and you're going to do algebra 1, you're going to do geometry, then you're going to do algebra 2. And if you're fortunate, then you move to calculus. All those things just build on each other. And so the cool thing is, as you develop understanding, you see the meaning of why you did algebra when you get to calculus. You can see why that all of those X's and Y's were very helpful when you start taking things like derivatives and you integrate. And so sometimes it takes a while to really see how that next layer is being developed. But when you do, it becomes a really cool thing. And there's teachers out there that do a really good job of helping you uncover and understand how things build upon each other, but they're probably not as common as we would like to have it, where more often than not, I think a lot of students just kind of learn something because, well, that's what the textbook tells you to learn, and you don't really understand why you're learning it. And that becomes unmotivating to learn it because who wants to learn about X's and Y's? What in the world is this ever going to do for me? And so I could see where there'd be a lot of bad perceptions on what math is because they lose out on what the meaning of what they're learning.
And I do think in the past, the motive of like a story problem was trying to do that. I think, it was the idea that let's make this a real world problem and then we can use math to fix it. But I think it almost got to, I remember I feeling that making junior high math classes thinking, oh, they're just trying to trick me with this stuff. It's almost like, it's almost a psychological problem, but no, I think they were trying to actually give us ways to see it in the real world. I'm not sure it always accomplished that. But I do think, I remember my first year calculus class, and I went to a small school in high school. So I think we had like 2 weeks of calculus just to show us what it was. But I was struggling a little bit. I was understanding but then I went back to those 2 weeks and I saw a line of what I was actually trying to do, trying to get areas under curves and rates of change. And I'm like, oh, that's what that means. And then everything fell on the meter after that, and it was, I'm going to say it was easy. You still got to work at it. But I remember telling a fellow student who had taken a calculus class at a high school in a city before he came, and he was just struggling. And I said, well, this is what we're doing. And the light went on for him too. And I think, I'm not saying it would happen with everybody, but no matter what we do in math or life, isn't it nice to know why we're doing it? Or even more importantly, maybe who we're doing it for.
Right.
Yeah. And trying to get people to understand that is kind of what we're trying to do, I guess, to some extent.
Sure. And another dimension to this meaning thing, when you mentioned about who, for me, one of the things that I've really appreciated just this last, I'd say 3 or 4 years, is as I've studied more math history, I've gotten to know more about some of the people who have made the large strides in math, the Eulers, the Newtons, the Euclids, the Gausses, and, all these different mathematicians. And as I study about them, many of them, even though they're brilliant people, way beyond my abilities, but a lot of the math that they worked on is very reachable for me. And, I just have a bachelor's degree in math education. So there's a lot of people that have a lot more math background than I do. But I can read a lot of what Euler did and understand what he said, and not only understand it, but really appreciate it. And so to me, it's really fun to read about the accomplishments and the milestones that these kind of heroes achieved in the history of math and to be able to almost walk in their shoes. And in doing so, I feel like it connects me to the past. I kind of was one of those people that I forget the term, Brian, what that was. I think it was a term C.S. Lewis had mentioned, something about when you kind of look
chronological snobbery.
Yeah,
chronological snobbery. Yes, I do.
Yeah, yeah. So chronological snobbery. That was a little bit of me, where I would kind of think about, anyone who lived before maybe computers were around just really wasn't quite as smart as us enlightened people were. And so that there was a little bit of that going on in my head, I think. And then as I started, of course, reading about people like Euler, I realized, wow, these people were brilliant, and they did it all without a computer. They did it in their head or with a piece of paper. And so it was like I gained a lot of respect for people from different cultures, different time periods. And I felt like I got to know them a little bit, got into their minds a little bit, and walked in their shoes. And that really, it was very contagious. And Newton is famously quoted as saying something like, because he invented calculus, and he was trying to communicate that, well, I didn't come up with calculus on my own. He said that if he's seen farther than others, it's because he's stood on the shoulder of giants before him. And I kind of feel like maybe I've walked in the shoes of some of the giants before me, in that you go through some of their logic and understand some of the things that they discovered. And it's just kind of neat to connect to it. And so I've been doing this for about 5 years, and I've accumulated a lot of books and got different perspectives on these things. And a lot of the different books and perspectives on this have common ground to it. And so you get a sense that, okay, there's a lot of truth to this, because what this one author is saying is the same thing that the other author said. But then each one will have their own little twist to it, where you get to know something a little bit different. And so it kind of feels like you're putting together a puzzle of these math people. And the more you read about them, the more pieces you're accumulating. And it just kind of develops me more as a person, because I get out of my own time and space and into something much bigger than myself. And I just think that experience is so cool.
Yeah, and as you were saying that, it comes back to that story idea that he kind of talked about, because you're reading his history. If you're reading the lives of these guys, you're reading their histories, so you get to know them a little bit, and you get to see their journey. I think I remember it was a great uncle of mine that was in World War II, and he became a history teacher, and he used the analogy. It's like when we were there, you really want to know history of the area when you get there. And I said, well, what do you mean? He said, right here is a map of the history of the landmines that are in this area. It's really nice to know the journey these guys went through before I start going, know where the landmines are, Right. So yeah, we want to get over there, but how you get there. And again, that's just kind of an analogy of how you look at Euler, you look at Newton, you look at all these different mathematicians, and what they said resonates with us, because we're on similar journeys, I think. It's going to be different. Like you said, we're in different technology and all that. And we talked about this, but that Henry Poincaré mathematician, when he said, Sue quotes him, science is built up of facts as a house is built up of stones. But, and this is a good but, an accumulation of facts is no more a science than a heap of stones is a house. I thought that was really well put. And it goes into that story idea. What are you doing this for? What's the meaning? And for me, as a kind of a philosophy guy, I remember the story back from the Renaissance time, when you come up upon these three guys, and they're all doing the same thing. They're all taking a bunch of mortar and a brick, and they're putting a mortar down, they're putting a brick on, and they're taking some more mortar, they're all doing exactly the same thing. So you go to the first guy and you say, hey, what are you doing? He said, I'm laying bricks. And he's doing a good job. He's kind of grumpy, but he's doing a good job. The second guy, what are you doing? Well, I'm building a wall. And so, okay, well, that's kind of cool. And then you go to the third guy, and his eyes light up, and he looks at you and goes, I'm helping build a wondrous cathedral.
Mm-hmm. Yeah.
All of them are doing exactly the same thing.
Mm-hmm.
But because the final guy knew why he was doing it,
mm-hmm.
it made the journey so much better. And I think that
Mm-hmm.
was an insight that kind of fit really well there. And
Right.
you see that, who would have known that came from a mathematician? You know, you got some of these quotes that you put in your stories they're just classical, good and deep, and both they're mathematical, but more philosophical. They're more about life.
Mm-hmm.
They're more about what has meaning here. And it seems like there's a thread between every one of those guys that you've researched and talked about and got the history of. They all had that. They understood what the meaning of what they were doing.
Mm-hmm.
And that's what gave them some confidence to go forward.
Right. And to piggyback off of that, another thing that really gives math meaning to me is its permanence. And that whatever Euclid identified as true of geometry 2,000 plus years ago is still true today. What I learned in high school is still useful for me today. In fact, not only is it useful because it's still true, but it's allowing me to learn new things. So it's like a foundation that I can build upon. So when I learn math, I get this opportunity to participate in this collection of truth that has been developed and manicured and massaged for thousands of years. And it's presented to me in a much better format than it would have been, even 200 years ago. And so I get the privilege of getting a polished version of it. And so I get to participate in this truth accumulation, but then I get to put my own little kind of like personality on it, in that I can see things differently than anyone ever has seen things before. And so I can have my own little contribution to this cathedral of math that is uniquely mine. And I think that is true of anyone who does math. And you may not think that you're super smart or you have anything to contribute to the world of math, but you really do. As you start thinking about things, just solving problems, you may have solved a problem in a way that no one ever has solved it before. And it's a way that is uniquely yours. And, you could tell someone about it. And that's one of the ways of kind of giving back to others, is to share what you've learned. It also helps you realize, wow, I just helped someone understand something. I really didn't learn something I didn't know yesterday. And I just learned it and I explained it to someone else and it helped them. And when I explained it to them, I actually learned it better because they asked me questions. I had to formulate deeper understanding in order to be able to communicate it with words to someone else. It just wasn't sitting in my head and my thoughts. And so there's just this working out of the math that is a personal thing. And so you got this combination of truth that math embodies, but there's individual working it out. And I know it sounds a lot like, what we experience in our spiritual world as well. And I think that there's a lot of overlap to that. And I think that there's joy in being able to be part of that and not sit on the sidelines and being passive.
Yeah, and I like the way you put that because, it kind of goes back to the idea of the intrinsic value of each human and the uniqueness of each human. We kind of use the word ontology, the idea of who we are, what we're made up of, but each one's unique. And so the way you approach anything, certainly relationships, every relationship is unique, no matter if there is 8 billion people in the world and have been, I think the last I read, it's like 113 billion people have ever lived. But that math easily, that's not a big number for a math major. It's like, well, yeah, but they're all unique. And when you engage in this stuff and look at things from a different direction, you're, like you said, you put it well, you're uniquely engaging that in a way that nobody else did because it's you and you have unique makeup. It could be similar to other people, but it's not going to be the same. And that, I think that's where the other types of thing, the joy, the beauty, the truth, comes alongside of the meaning. So
Mm-hmm.
So as we finish up here, he gave us another definition of mathematics toward the end of this chapter, which I thought was kind of
actually,
cool.
I was going to end with that quote.
Yeah, why don't you go ahead and end with that? That would be great.
Yeah. And so this is the quote I believe it's at the end of the chapter. And Sue says, meaning comes from thinking abstractly. Thinking abstractly does not strip away meaning, but adds to it. It finds what is essential. In reality, there is more to math than its utility. And beauty is found by reflecting on an idea's many meanings as we swivel from perspective to perspective. So this is Sue kind of coming up with his conclusion. So I prefer to say that, and this is how he defines math. Mathematics is the science of patterns and the art of engaging the meaning of those patterns. And so I think that is, kind of a good way to wrap it up. And maybe on top of that, I think about math as also like this universal language that we have as humans that can kind of bring us all together because we all speak that same logic regardless of where we're coming from and when we have lived, on this earth.
And I think that is good to wrap up with that because it's so cool that he sees mathematics as both an art and a science, which I don't think a lot of people would see it that way. So thanks for joining us. This is we're going to continue on with this in our next podcast about talking about different chapters from this great book. And I do encourage you to get it, Mathematics for Human Flourishing by Francis Sue, a great resource to look into, whether you're a math geek like we are, or you're just someone trying to find some meaning and maybe some patterns in your life.
This has been the Intersecting Us podcast. To further engage with Intersecting Us, go to intersectingus.com.